Welcome to the Lightware HDBaseT Back to the Present webinar with your host, Jason Tirado, and my good friend and colleague, Brad Spurgeon, Director, Technical Sales, Americas. I'm going to share my screen. Don't worry, we're not going to PowerPoint this thing to death. I'm not a big PowerPoint fan. I think I have like 12 or 13 slides. It's not going to be PowerPoint heavy. We do have a few things we want to show you just with some, reference visual material. A lot of it's going to be online. Brad's going to lead a lot of the discussion. What we're going to do, just talk a little bit first, just about the subject, Lightware, the company, why HDBaseT right now? Why are we talking about this right now? Some of the naming conventions of the products, because that's often a mystery. If you're not really familiar with Lightware, a lot of times it's difficult to tell what we mean when we're, putting together these letters and numbers, and I'm going to demystify that a little bit. We're going to talk about some of the open API, diagnostics, analytics, the things that Lightware is well known for and famous for, the things that made me first fall in love with Lightware, and I think you're going to enjoy as well when you get to know about it. We're going to look at some technical drawings, and so we'll actually look at a real room diagram, talk a little bit about some of the ideas there to use Lightware products, and at that point, we'll probably have some questions posted for us. And so if you've got questions throughout this program, please just use the little chat feature. Go ahead and write them in. Or, Brad will look at them, Levy will look at them in the meantime, and then we'll try to get as many answers for you in real time as we can, okay? So with that being said, we're just going to start sharing and jump ahead into this presentation. And so if you can see my screen, back to the present. So as when I'm making up titles for stuff like this, I try to pick something that means something. And of course, that Back to the Present is a reference to a movie that came out like 40 years ago called Back to the Future. And the reason I was using that was because, everything's changing in AV and things are changing in our industry. And one of the things that people are migrating towards as part of the future is the AV over IP. And while certainly we've got some offerings in that category, there's a very substantial, robust, and well-defined offering for HDBaseT products from Lightware that has been available for years. And in my opinion, as good as AV over IP is, it's not as simple as spelling it. Anybody that's done it knows that there's an immense amount of coordination with the Ethernet switch, the very thing in the very middle. There's all kinds of protocols, IGMP, snooping, multicast traffic that may or may not be implemented on a given Ethernet switch. And so, look, frankly, although there's some great situations for that, it really requires a lot of knowledge about the Ethernet switch, the configuration, and sometimes it's not as easy as just doing HDBaseT. And so in smaller systems and in some of the even larger systems, HDBaseT is still a very, very reliable option. And I think it's going to be around for several years. So one of the big questions we get hit with all the time, right, is where's your availability? And we put the availability in AV. We put the AV in availability. We have stuff right now ready to go. We've got transmitters. We've got receivers in Michigan. If you place an order, I can ship your order. We have a lead time of maybe 4 to 8 weeks on larger quantities or maybe larger models, some of the bigger models of some of the HDBaseT stuff. So there's a chance if you place your order now, I could ship it this week, next week. If you have larger quantities or some models that we don't have on hand, you can expect about a 4 to 8 week lead time. My understanding is that's not too bad in today's world, and I consider that readily available. So we have got them in stock, ready to ship. Thank the Hungarian headquarters procurement department, because a while ago they stocked up on a bunch of different components, so we'd be in this position right now, and we're in a great position as far as availability goes. So if you don't know Lightware very well, we are a Budapest headquartered company made of engineers. I like to say Lightware invents, because that's what we do. We have over 80% of the engineers at Lightware have master's degrees or better. The university in Budapest is a world-renowned, respected engineering school, and we get the best and the brightest folks that come out of there. Computer science, software, mechanical, electrical engineers are coming out of there and getting employed by Lightware. And we're getting the benefit of that, being able to listen to our customers and also go back and create some of the future. Here you can see we're all over the world and getting bigger every day. Again, if you're new to Lightware, we make a lot of different products. I'll tell you, the way to think about it is connectivity and extension solutions. connectivity and extension solutions. That can mean HDMI, DVI, fiber, optical, all kinds of different areas. But today, we're just going to focus on the HDBaseT stuff. So as you can see, these little icons that are popping out right now, HDBaseT is the focus for today's webinar. Okay, so again, if you haven't spent your years with Lightware and you're just coming in, sometimes this stuff can be a little confusing. And so we want to break this down to something a little bit easier to go after. And the first thing we thought of was, let's just talk about the use case. What are you trying to do? Are you trying to go point to point? If you are, well, you're in this little category right here. If you're just trying to do some signal switching, well, you can be in this category down here. And you can see that within this point-to-point extension land, there's the HDBaseT protocol that we are compliant with. And then there's also some families of products. This Lightware solution column shows you some of the families of products. And here's where that TPS comes into play. When you see TPS, that means Twisted Pair Series. Twisted Pair Series is equivalent to HDBaseT. So if you see that in the model, you're going to know that that's an HDBaseT compliant product. There's a few that don't have that in there, but everyone that does is compliant. Now, if you look over here under specific products, those first couple of characters will tell you something about the format for the connector. In this case, you can see a couple of HDMIs and see HDMIs. And then TPS means HDBaseT, Twisted Pair Series. Okay, I know what I'm in as far as protocol goes. And then you can see a TX or RX, which is a very common abbreviation for transmitter or receiver. And so if you know that, you can actually start to get quite a bit of information just by looking at the actual model number. And now we've kind of blown it up a little bit. So why are we doing it this way? Okay, the HDMI, that's your connection type on this particular product. There it is, that HDMI connector. TPS, Twisted Pair Series, right in the middle, tells me we're in the HDBaseT family. Oh, and look at that. There's a TPS output on this product, so I know I'm in the right place. TX, it's a transmitter. Okay. Now, just like when you're learning English or you're learning any other language, there's rules and then there's exceptions to the rules. And you don't get too caught up on the exceptions. Just know that that 210 has got something to do with the inputs and outputs, or in this case, it might just be a designation for some feature sets. So 96s, 97s, just so we can tell the difference between certain varieties and what they do. But you can get a lot of information just by following along with these little models and taking a look at the way we name things. When I first came to Lightware, I'm coming up on 6 years. It's 5.5 years just about right now. I was in Budapest and I got a chance to go and visit with the folks that create this hardware and create the software and see the invention actually taking place. And one of the first things that made me fall in love was the way the company valued information, the open API, truthful and honest open API. We have got an open application programmer's interface that is documented. If you want to know about how to control a Lightware device, see a Lightware device, monitor a Lightware device, manage a Lightware device, you can go to that user's manual, you can open up and you can see every single command documented. So you don't have to wonder, you can know for sure. And it's in Lightware's DNA to make this information exposed to everybody, not just us. This is not just Brad looking at that information and you being blocked out of it. No, this is everybody should be able to see this. On the Lightware website, you can download our software. When you open up our tools, you can see the signals and the diagnostics and analytics going through, and we're going to look at that more in depth. But if you're interested in management and monitoring of your systems, I believe we've got the most robust, open, documented API of anybody out there. And take a look at it. I think you'll like it. So with that being said, I'm going to get you out of PowerPoint. We're going to turn it over to Brad, and I'm going to ask him to kind of follow up with some of the software and hardware to demonstrate what it is we're talking about. So Brad, can you take it away?
Yeah, absolutely. So give me one moment here. I'll get my screen shared for you, and we're going to pull up our software that we use to manage all Lightware devices, all manageable Lightware devices. It's called Lightware Device Controller. Jason, can you let me know if I'm sharing the right screen with you? Perfect.
Or sharing
Excellent.
it, I can see it.
Awesome. So what you guys are looking at right now is, I think, something that is often undervalued with the manufacturer, which is the ability to connect and manage multiple devices from different product families with one single piece of software. And when my quick story is I have, more than a decade in IT. I'm used to having multiple vendor specific softwares running on my laptop for any site visits. I'm used to even having, let's say, a different piece of software for the same network switch, but is on a different firmware version. So having one piece of software that all I have to do, I can install, I can connect to my completely uncompressed AV over IP, the only device in the world that does it, Ubexes, all the way down to my simple smart extenders. I don't have to carry around a bunch of pieces of software. So as a tech person that as I am, this is probably one of the most well-respected features that Lightware did, and that was before I joined this company over 8 years ago. So I want to walk you through one of the products that Jason was pointing out, and the product's called the MMX 8x4. The MMX 8x4 is an 8 input, 4 output. So I'm going to get connected to that device right now. I'm going to tab over. I already connected. A little cheat for you guys. And so what you're seeing right now on this 8x4 is a representation of the simple crosspoint routing representation on this device, and I can get a quick snapshot without looking at diving into any details of what is exactly going on. I can tell that my input 2 and my input 3 have a green indication. That means that there is an active signal on those inputs. I know my input 1 doesn't have have a signal indication. So as a tech person that might be looking at a large amount of deployments, I can quickly see that, hey, I might have an issue with my first input. And I don't have to dive into a bunch of menus or anything like that to quickly recognize what's going on. Now, Jason talked a lot about what we offer as a hardware manufacturer. One of the ways that we always talk about what we do is we're more of an information company than a hardware manufacturer. Yeah, we manufacture hardware, but really what Lightware does is provide a robust amount of detailed information about those signals to allow your deployment team or your service team to quickly acknowledge and recognize any issues in the system without having to pull out cable testers from the very beginning and start testing everything along the loop. So I'm going to open up the input property for input number 2. I did that by clicking on the input number right there. And immediately I am met with all sorts of information about this input right here, clearly represented on my device. So I know that, this connection is an HDBaseT, which is the subject of the matter here. I know that my incoming video signal resolution is a 1080p 60 hertz signal at 8-bit RGB. I can open up this tool called the frame detector. Now, frame detector is an amazing piece of technology. So this is actually reading what the HDMI chip reports to us. So basically it's a signal analyzer that's available on every single input and every single output of this device. So I can tell that I got a 1920 by 1080. I can tell the actual blinking area total data, horizontal and vertical information as well. And to keep on the subject matter, HDBaseT, we have this tool called cable diagnostics. And so this tool is extremely powerful because this tool is not a Lightware proprietary piece of information. This tool actually is collecting data that is available for every manufacturer from the valence chips themselves. Those chips actually, it doesn't matter if it exists on a DigiLink Panasonic projector, native HDBaseT connection, NEC, or any other manufacturer native HDBaseT connection. On the Lightware side, that information is present. We're an information company. We're showing you what's going on. So if you take one of our, let's say, matrices and go straight into an NEC module or straight into a projector, Panasonic projector or any other HDBaseT projector, we can still pull this information that is actually telling me very detailed data about the pairs of the connectivity between those two chips. So I can quickly have a look at this and tell, am I getting an error on a certain pair, right? And that'll help us kind of quickly deduce where an issue might be. Of course, we have a complete table inside the system, and I can export this data So if you have an issue and say, hey, for some reason we're having this intermittent issue, you can export this information as a CSV, send it to one of our support guys, or send it to one of your internal support teams, and they'll be able to read when the error happens, everything being timestamped as it goes along. So it's tremendously powerful, tremendously helpful, and this is native to the Lightware device and actually native to the Lightware ecosystem. So any managed smart extender, any managed matrix, which all our matrices are managed, will have frame detector, which is the reading from the HDMI chips, and they will have cable diagnostics if it's an HDBaseT connection. And all that's included on every single input and every single output of the device. So if you have an HDBaseT output of a smart device or a managed device from Lightware, you're going to be able to grab this information. It's tremendously powerful. And it's just like having either a quantum data or a Meridio on every single input, every single output at the same time.
Brad, can I just emphasize something? I think you said it, but I'm just going to say it again because I think it's so important. This cable diagnostics tool that Brad just showed you, that physical layer testing tool, where most often the problems actually reside, and I think Brad knows that better than anybody. This is often physical layer stuff. That is not proprietary to Lightware. That's a function of the HDBaseT Valence chipsets. And so what Brad is showing you with that cable diagnostics tool, if that was connected to the input on a Panasonic projector and there was some problem in that physical layer, you would see it. You would see it right here. And if somebody rolls over that cable or bunches it up and messes up the transmission data of that cable, you'll see it in real time on this thing. And so whether you've got somebody else's HDBaseT transmitter or receiver, if you've got a Lightware, you've got the information you need to know that your physical layer is integral. Thanks, Brad. Just want to reemphasize that. Thank you.
Absolutely. And there's many scenarios where you have existing HDBaseT deployments. You may have a receiver or a transmitter or even the matrix that might fail on you. There's many scenarios that we come in that we bring in our HDBaseT device. And because HDBaseT is an established standard, it works. And now the end users or you or the deployment team now has a whole bunch of data that you can collect on an existing system, maybe to increase the longevity of that system as well. I want to transfer out of this just a little bit and show you a couple of little cool features that, are sort of, I like to pretend, we all like to pretend that, we have, omnipotent engineers that know everything. But the reality of it is a lot of the stuff that you're going to see is feedback from end users like yourself who encountered these issues, encountered the problems, and our engineers took that feedback and helped develop this. One of the most important things that is at the core of Lightware, and it's really what put us on the map of all those big, large events, the Cirque du Soleil, Metallica shows, and all those sort of huge shows, is EDI management. It seems very simple, and now most manufacturers do it to some degree or the other. But Lightware was one of the inventors of actually having EDI management on an actual matrix itself. And so this EDI management allows me to quickly assign and view or create custom EDIDs all within the system and assign them to the Lightware device itself. And one of the great things about this is Lightware as a system, we don't really care about resolutions. We care about bandwidth. And our systems are often used in these large productions or even just simple video walls with very obscure non-VESA standard resolutions. And because we have this EDI creation tool, you can actually use the Lightware device to create custom EDIDs within that space to be able to manage your system so you don't have to dial through a bunch of, let's say, menus on certain source devices, or maybe it doesn't even exist as well. So complete, robust EDI management on every single managed Lightware device. So from our smart extenders to our big, super huge matrices to our 1,000 endpoint AV over IP systems, complete EDI management across the board. I'm going to skip through the control section of this because this just kind of shows you what I do like to show is that we have a whole variety of information that we pull and options. I like to skip over that and go to the events manager. But before I jump into anything here, I do want to tell you guys something. Everything that you're seeing me do through this interface is completely available in our open API. It's available and it's documented. I encourage anyone to go into our in any product available on our website. You go to the product page, you click the file downloads, and you're going to see a user manual. There's a section called Programmer's Reference. I think it's usually chapter 7. Sometimes it varies, but I do believe it's chapter 7 almost every manual. And this is going to outline our open API. And, Lightware, we want to work with everybody. It doesn't matter what sort of Tron-based control system or whatever you're using. We're there to work. We'll work with PuTTY even, and I'll show you some cool things to do later. So I want to take a moment and apologies if I'm going a little fast for you guys, because I know this is very exciting. There's a lot of information here. And I want to talk about something that we all encounter, and it's obviously a growing thing, which is room automation. Room automation, such as, when somebody walks in, they want the displays to turn on. When somebody walks out, they want the displays to turn off. Traditionally, that was a little bit more a complex operation than it ever had to be. You usually had to have a control system that constantly pulled the status of a device, and when that status changed, then it performed an action. Like, it was constantly looking for somebody to connect something. So you'd have a control processor in your server room constantly looking at all these endpoints, or even buying control processor per room. That's all it did. What our engineers did, as feedback from the community, is we added a lot of those features native to all of our managed devices. Event Manager is basically an on-device condition-based programming that you can set up to accomplish a majority of the tasks that you're going to accomplish in a normal environment. So one of the most common scenarios that I always tell people about is, you plug your cable into to your laptop. You want the display to turn on. That's not too much to ask. That's a very common thing. Traditionally, you'd have to get a control system. You'd have to pull an endpoint to check, and you'd have to then build that action. On our device, I can build that just really easily from this wizard. So I'm going to enable the event. This is where I joke. I always tell people, it's like, you got to enable it, because if you don't enable it, it's not going to work. And that's usually when I get a call back from someone who says, I couldn't get it to work. I forgot to enable it. So great scenario. Jason walks into the room. He wants to plug his laptop in. He wants the display to turn on, right? So let's make that happen. So let's say category, it's a video category, right? It's video signal. Video signal is detected on a port. I'm using an 8x4, so I have 8 inputs. I do have a 5th output right here, but that's actually the analog audio output. So we're going to say, we'll just keep it simple. We'll say input number 1 is where Jason hits his laptop. The next, if I just follow these arrows down through the system, it's going to guide me through here. And again, this is fully documented in the user manual with screenshots, which is great. I can add a simple delay or continuous to play. So let's just say we want to wait for 3 seconds. No, we want it to still be true after 3 seconds. So it checks and then waits 3 seconds and checks again. And then now I want to turn on a display. If I select this category, I have a whole wide variety of control options. I can do CEC, right? So if someone forces you to use a consumer display, or CEC is a lot more robust than it has been over the years. I can use Ethernet control. I can use RS-232. I'm going to select Ethernet. I have a wide variety of Ethernet control available. I like to keep it simple for the presentation. I'm going to just choose TCP. I'm going to say turn on display. Please, we all know that's not the right command, but you get the reference, right? So I'm going to put in a fictitious IP address with a fictitious port number. That's it. I am done. When video signal is detected on input number 1, this will wait 3 seconds, and then it will turn on the display, or it'll send that command to turn on the display. I didn't have to pull any endpoints. I didn't have to do anything. And the beautiful thing about this is the commands that I've changed actually push to the device. So when I get ready to leave the site, I unplug my laptop and I leave. I don't have to have an on-site control processor. I don't have to have a NUC or some sort of stick PC constantly running the software to do it. That information is actually running on the processor of the MMX 8x4. Another great scenario, and I like to tell people, when we think about bigger deployments, one of the big pushbacks for IT teams is, how are you going to piggyback across my network? What sort of bandwidth are you going to use? There's a lot of considerations that you have to take into place, or a lot of things you have to take into consideration for these larger deployments. And so if you imagine having multiple rooms in one overall building, and you want every room to sort of operate independently, but still also report back to some sort of building management system or some sort of centralized control processor. With the Event Manager, you can do that super easy. So I have my video signal here, right here. It says video signal detected on input 1. I want to send a command to turn on the display, but let's say I also want to kick that back to a Tron-based control system, or if I want to kick that back to some sort of building management, I can actually create a second event. I just enabled it. Don't forget that. I'm going to link that second event to the first event I did. So video signal detected on input 1. I hit apply. And then now I want to send, let's say, we'll do another Ethernet command, but we'll do it as a UDP command because, we don't care about packet checking. So we're going to say, someone is in room 2009, right? Super large building, whatever the IP address is of our management software, or whatever command that they need to receive on that back end. Now, this room, when someone walks in, they plug in their laptop, I'm sending a command to turn on that display. And I'm also sending a second command back to a central control processor. So if you have a building network that goes down, let's say, a really great scenario, someone brings in a consumer display. So we're going to actually go through here. We're going to change this to CEC. And then we're going to say, scroll it down. We're just going to say power on, hit apply. Now, if I have a whole network-wide dropout, I'm still sending CEC to power on that display, and I can still push that command to the control processor. But if the control processor receives it or not, it doesn't matter. The end user's display still turns on. They can still operate the room in that sort of facility while the team builds back up. So you can actually, with Event Manager, you can run these rooms sort of automated as themselves as sort of closed ecosystem, but still get that advantage to push data externally. Now, I always use the video signal is detected on an input as a reference because it's one of the easiest things for a lot of non-programmers to visualize. But if you're a programmer, and let's just say that you're a programmer and you know a lot about setting things up in a lot of variables. If I showed you the wizard, if I click on the advanced view, it's going to warn me. I can use any of these as parameters. So one of the most common ones, let's say if HDCP is detected on that port, send that command. If the status changes to 3D, right? I know that's probably never going to account for the 3D, but I just want to show how deep down that you can actually get just within Event Manager. And here's the best part of this, right? So not only do I not have to have a standalone control processor, but I'm going to roll right down here and click on this advanced view. I can utilize the full open API of the Lightware device. And the beauty of this is I can dial down to any single parameter, and I could use something like, let's say, PuTTY or whatever it is, and I can actually get information from this. And I always say this is honest and open, and we're really truthful about that. If I have access to it, you have access to it. So there's no special code that you have to put in. There's no classes you have to pass in order to actually see or access our complete open API. And everything I showed you via the command interface or the GUI interface via Lightware Device Controller is obviously available via our open API. So there's tons of robust feature sets. It can easily implement with existing systems or even implement with newer designs as well.
Brad, one of the things, again, you show me here that I always think is so interesting, because you and I get into these discussions with people in designs. Sometimes they want to differentiate between 5 volts present and signal present. Like there are reasons people want to look for the various subcomponents in there, and just seeing it all here as plain as you can get it. And the other thing that I always love in this little view is that little LW3 protocol help button that's up there on the top left. Because when you click on that, suddenly you get a new just online description of exactly what Brad is talking about. Oh, you want to subscribe to this? Oh, you want to know what this prefix means? Oh, you want to know what this node? It's all right there. It's very, very open. If you're okay with wrapping up this portion, Brad, I'm going to take it back over and dive back into the PowerPoint. Okay.
Absolutely.
Sounds good. Great work. You know, simple logic done simply. I mean, that's what you're showing there. You know, is if we're trying to do some simple things, we can do them pretty simply. And you know, I know you're a smart guy, but you're hard to come by. You know, not everybody has somebody like you hanging around. All right, so let's say I'm showing this. Can you see this, Brad? The Panasonic Connect Digital Link thing. So, look, guys, folks out there, this is a Panasonic document that's still online. We'll share the link if you want it. They did a lot of testing about HDBaseT compliant products, and so this is information that they have. I'm gonna scroll down and show you. You're gonna see some yeses. You're gonna see some nos. I don't want you to think that I'm here to denigrate any particular manufacturer. I'm here to denigrate all manufacturers that are not Lightware. Take a look and you'll see these no, 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 yes, no, 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 yes, yes, no, 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 yes, 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 no, 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 no. Oh, wait, here's Lightware. Okay, now we're in the yes game. We are saying yes, yes. Do you want to do this? Yes. Yes, yes. And you can see they went down, they did a lot of connectivity tests for Lightware products. And it just makes me happy looking at it, you know, just knowing that we've got this kind of third-party validation from Panasonic that shows just what Lightware is capable of. And we get a lot of yeses. So a lot of yeses is good. If we move on, let's talk about an actual room now. Okay, so we've spent time talking about the protocol, we've talked about the software tools, we've talked about diagnostics, analytics. Well, we still got to build a room together. So I told you before, you know, about the lessons that you're going to learn by reading the model here. So I'll just take you through what this is. At the heart of this application, this is a multimedia matrix. So that multimedia matrix is what the MM stands for, and X is a good indicator. It's a matrix switcher. 8x4, that's usually going to be inputs to outputs, right? So this is an 8 input to 4 output device. In here, you'll see that's HT, which does stand for HDBaseT in this scenario. So I know TPS is the key word that we look for, and we're looking for HDBaseT. In this case, this also means that there's HDBaseT here. Oh, let me go back. So now that we've got this, and the numbers are right there, again, that tells you something about the model and the capabilities. But down here, we got some transmitters. And when you see the U, universal media matrix, that U usually means there's a VGA connector on it. So that might not be as important for everybody right now, but that just kind of tells you some of what you're looking at here. If I see WP, I know that's a wall plate. So I got a wall plate, universal media transmitter with my HDBaseT target right there, and a transmitter. I know it's a transmitter, it's got TX. So Brad, what do you see when you're looking at this thing? What does it show you?
Yeah, so what the diagram is showing you is the same system that we walked through with the event manager. And what we're showing in this diagram is, you know, sort of a mixture of different formats coming into a system, being fully matrixable, fully routable, non-blocking, which is, you know, it's interesting that we always have to mention that, or, you know, because there are other manufacturers that limit, you know, that have like sort of like a shared bandwidth, right, where you can only route so many signals to here. Lightware is not that way. So what I have right here in the schematic is I'm showing a wall plate that is being PoE powered from the matrix. I have a, you know, maybe an extender. Right now it's the UMX. It could be a whole variety of extenders also being remotely powered from the matrix itself. And then on the output side, I'm going an output into one of our HDBaseT receivers. Again, with that receiver and the Lightware matrix, I'm going to get that complete cable diagnostic, and then I'm converting that HDBaseT, that, you know, that pulse amplitude signal back to a TMDS HDMI signal into the projector. And then right next to it, you'll see an HDBaseT projector with the native HDBaseT connections. That might be that Panasonic DigiLink, or it might be an NEC display or some other manufacturer that, you know, that works with the HDBaseT. And then, of course, I have some local sources, and then this device does have the ability to take a microphone in and be able to do, you know, mic mixing, or tie it into a DSP if you want to do some, you know, more complicated sound reinforcement and that sort of stuff. With this system in this place, and this is a very, very common design, right, that we do often with these 8x4s and some smart extenders, and especially wall plates as well. with this system, you can run your room fully managed, as we described in the event manager section. I can control my right here. We're showing a relay connection. I can control the screen up and down for the projector. I can build that in the automation, and so there's a wide variety of control and routing available. From what would relatively be a complex system. Right now, it's just simple. Right.
I think you spelled it out really well, Brad. And one of the things I like that you said there in your wrap up is it's control and signal routing. Because there are systems where they're not combined. In our case, they are combined. So you do get that controllability using Event Manager and some of the protocols you talked about, along with the events, right, that are coming in, signal presence and stuff. So here's a different application diagram. This one is built around a media matrix switcher, which has got a frame with 17 potential inputs and outputs. This is going to be built up with a combination of input and output cards. And so in this case, maybe Brad, talk a little bit about what you see here when you're looking at this design.
Yeah, absolutely. So the central core of this system is an MXFR series, right? So the MXFR series is our modular matrix series. It's card based. We have a wide variety of cards, everything from optical to HDBaseT. As I said in the presentation earlier, which still applies, if this is a managed device, which it is, we can still get all that HDBaseT link status. And so in this system, which is, like if you're imagining a live event or you're imagining like a larger room, we can take, I believe all the way up to an 80 by 80 source inputs and outputs via cards and mix and matrix those all together. Now, for all of our HDBaseT extenders, right? So we have our HDBaseT DVI, HDCP, TX220 right here at the front end, and our receiver. I guess we tab back out.
Tabbed out.
Okay. It's all good. It's all good. Those can be remotely powered from that centralized matrix. And so one of the beautiful things about that is you don't have to fight for only having 2 ports at a display and one's using your NUC or whatever. We can do the remote powering management and provide one unified interface and one unified connectivity for your control system if you want to use a standalone control system to be able to permeate information throughout the system or collect information about link status via our open API. So this is, if you imagine the first one being kind of like a small room, this would be like your medium to large size room. And of course, this can scale up to be a very large, even facility or campus wide system as well. All completely addressable, every endpoint, all the information available from the Lightware device controller that we showed you earlier or via our open API.
Hey, Brad, one last thing. You kind of touched on it, but just spend a couple more minutes on it, and then I'm going to take us to the wrap up. The power requirements. So you've got this power send and this receiver. We've got a couple of options as far as getting power to transmitters and receivers. Can you just touch on that for a second?
Absolutely. So as we know, PoE tends to be a directional type of power delivery, right? So in a situation like this, we'd have our matrix. Our matrix can send power out to the endpoints themselves. So we make a variety of endpoints that are ready to receive power from a matrix, whether it be this one or a larger one or a smaller one. But we also make devices that can be powered directly from each other. So we have a series we call it the -6 series. So it'd be an 86 or a 96 or a 226. But essentially what it is it's a bidirectional power that allows in a point-to-point configuration for the receiver to send power to the transmitter. So let's say you have a display at the wall and you obviously have to have power for the display, but you got a spare outlet. You can power that receiver and that'll send power over to the transmitter that's under the desk. And so that makes sure that, you can do these deployments without having to call for an extra power drop, at the table. It's bidirectional power. So my transmitter in that scenario if I put power there, it can also send power all the way back to the receiver to remotely power the receiver. So we do make a series of devices that are in point-to-point configuration. So if you're looking at just simplified HDBaseT extension, you're not really interested in matrix. You just need to get a 4K signal, 300 feet away. We do make them in point-to-point configurations, and then we also make series that works in these larger matrices. So kind of adapting to that. And in this scenario, the larger matrix is actually remotely providing power to every other Lightware endpoint in the design.
Sweet. All right, I'm gonna take us home now. All right, folks, you spent about 40 minutes with us. I hope it's been a good use of your time, but it's more than just sitting back in your chairs, looking at the screen, listening to Brad and I. You've got to do something now. What are you going to do? Well, you got two options, or take both. I don't care. But number one, send us your system drawing. Send us what you're working on, a drawing. I'm being very specific here. I am not saying send me an Excel spreadsheet of your competitive products all listed out and ask us to guess at what you're trying to do. That's not helpful. We can't do that. Our products do different things than other people's products. Their stuff does different things than ours. It's not a game we can play. But you can send us the drawing of their stuff all hooked up. You can show us the number of sources and displays. You can show us the distances. You can show us the formats. You can show us the infrastructure. And I don't care if it's got other people's stuff on it. We'll show you how we would do it with Lightware. But get us a drawing. Get us your drawing. Let us take a look at it. Let us work with you on it and show you the way that we would do it with Lightware. I think you're going to be happy with what you get back. So please take advantage of that. You can do that to sales.na@lightware.com. We'll reach out to you, set up an appointment with some of the smarter guys if we have to. The other thing you should be thinking about and doing is coming to visit us at the Lightware Discovery Center in Las Vegas. So everything that Brad has shown you today, everything I've talked about, and all the other stuff on that big list of equipment that we make is at the Lightware Discovery Center. You can see the AV over IP in the 1 gigabit network. You can go see the 10 gigabit AV over IP called UBEX at Illuminarium or War Studios as part of your tour. You can drive over a car with a tank. You can shoot a machine gun. You can have multiple cocktails that we would buy for you. It is a great place to go. You'll meet Big Al, who's in charge of the Lightware Las Vegas Discovery Center. So there is a place on our website you can go and find out all about it. Hang on. No, I'm not going to leave this thing right now. I'm just going to show you this Discovery Center, and you're going to see this when you log off of our presentation today. But right now, you should be able to see that. Welcome to Lightware Las Vegas Fabulous Discovery Center. Come visit us. So here's what happens. You pay for your airfare, you pay for your bus ticket, however it is you want to get to Las Vegas. When you get to Las Vegas, we'll come pick you up. We'll pay for your hotel. We'll pay for your meals. You can come in on an evening, spend the night. You'll get dinner. You spend the night. You wake up early. You spend a whole day with us, and we'll take you through hands-on. You'll see the AV over IP. You'll see HDBaseT. You'll see the Cisco integration. You'll see the Taurus stuff we haven't even talked about yet. You'll see all that in a full day. You'll go to dinner, do whatever you do, go to bed, wake up in the morning, and you'll have another half day. And you'll get out of there around 12 or 1 on that second day, and you can get back home to your family and your loved ones. Please come join us. Take a look at this. There's registration sessions available. Like I said, get yourself to Las Vegas. We'll pay for everything else. We want you to come by. Thank you so much for your time today. We'll look forward to getting your drawings. We'll look forward to seeing you in Las Vegas. We'll look forward to just what the future holds. It all looks bright right now. Have a great day. Have a great week. Thank you, folks. Take it easy. Bye-bye.